Hello everyone, today I am going to speak about mutation and selection in strain improvement. So the topic is very important in industrial biotechnology as it helps scientists to develop microorganisms that produce useful products more efficiently, such as antibiotic, enzymes and biofuels. So let's first understand what is exactly strain improvement. Strain improvement is the process of improving microorganisms so that they can produce more useful products. Scientists either select naturally occurring strains or create genetic changes to increase their productivity. These improved strains are widely used in various industries or manufacturing companies for manufacturing antibiotics, enzyme, biofuels, organic acids and many more other things. So there are three main core pillars for the mutation or improvement of strain. So the first one is genetic variation, where mutations create diversity in microorganisms. And the second one is selection pressure, where microorganisms are exposed to certain diversities or certain conditions so that only those with desirable traits survive. Only those who have the highest trait survive. And the third is screening methods, where scientists identify the best performing microorganism strains from thousands of mutants using modern laboratory techniques. So these three are the main core pillars of strain improvement. And let's talk about the types of mutations. So again, there are three main types of mutations, which include spontaneous mutations, induced mutations, and site-directed mutations. Mutagenesis. So in spontaneous mutations, it occurs naturally without any external influence. It doesn't need any external influence to occur. Spontaneous, as it goes with the word, it is spontaneous. It can occur naturally anywhere and anytime. And induced mutations, which are created intentionally using physical agents like UV rays or chemical mutagens, or to increase the mutation frequency. So the third one is site-directed mutagenesis, where the scientists use precise technique to introduce specific DNA changes to improve enzyme activity or product formation. So when we move further, the mutation process. Okay, so what exactly does mutation process, what are the steps of mutation process? Let us see. So the first step, it includes four main simple steps. So the first one is microorganisms are exposed to a mutagen, then surviving cells are isolated in them, and then scientists screen the different variants. Finally, the strains show better performances are selected for industrial use. Finally, the strains that shows better performance are used for industrial use. So what are the selection techniques? After mutagenesis, mutations occur, the best strains need to be selected. One method is direct selection, where only microorganisms with the desired traits grow on selective media. Another one is the enrichment culture, which increases the number of useful mutants. If a mutant is seen to be useful, then the enrichment culture helps it to grow more, helps to increase the number of the useful mutants. And the most advanced one is high throughput screening, where automated system rapidly tests thousands of colonies to find the best producers. So when we move forward, mutation outcomes. So not every mutation is beneficial. Around 62.5% of mutations are harmful or lethal, and around 20% of mutations produce just they show no improvement, and around 12.5% of mutants produce weaker strains, and only about 5% of mutants become improved strains with higher productivity. These rare mutants are what researchers or scientists are looking for strain improvement, during strain improvement. And when we move further, okay, so the industrial applications. What are the industrial applications of the strain improvements? So strain improvement has many industrial applications. Improved strain of penicillium can produce much more penicillin than any original strains. And scientists also develop microorganisms that produce enzymes used in detergents and food industries as well. Recombinant microorganisms produce insulin and specialty enzymes. And improved yeast strains are used for bioethanol production, while engineered bacteria and algae help produce biofuels and other valuable chemicals. So at the conclusion, when we to conclude, mutations and selections are powerful method for improving microbial strains. They increase product yield and reduce product cost and make industrial biotechnology more efficient. Today, in traditional mutation techniques are combined with modern genetic engineering and metabolic engineering as well to develop even better industrial microorganisms. And here my presentation ends, and thank you for your attention, and I hope this presentation helped you understand how mutation and selection are used in strain improvement.